This week, later on this week, perhaps Friday, I think realistically Friday afternoon, I am planning to post the second quiz. So the second quiz for our quiz is going to become available, and that quiz, I suggest that you spend very significant time preparing for it in terms of like every day. Don't be shy to go there every day and practice. There are lots of questions. The questions are extremely tough. They are really tough. And today we're going to start covering the topics related. The quiz does involve a conversation about functions and parameters, but it also involves a conversation about direct access to memory. So let's get started. To get started with this new set of topics, because I'd like this to move a little faster. I'm not going to use an official presentation. I'll just try to give you some examples, just basically going right back to the code window. All right, so I'm just getting rid of this. Okay, and then I'm getting rid of my lovely ping pong parts, which is fine. And I am going to erase everything except this. Now, we're looking at programs written in C, and we use components of C++ simply because it's just like, I don't know, it's my habit to use C++ output library as opposed to using C facilities. So you'll have a chance to learn C functions and their interaction and parameters in your C course, okay? Where I'm not focusing on C. I'm focusing on, macro things like computer memory, variables, functions, calls, like, big building blocks. Okay. So anyway, the promise of C is this. The promise of C is this. When your computer wakes up, right? When your computer wakes up, it sees computer memory as this, like long array of like memory cells, okay? Just like this, and so forth. And they're all numbered, and they're numbered zero-based. So this memory cells is 0, 1, 2, 3, 4, 1000, 1001, 1002, and keeps going and goes up to like 4 gigabyte right here. You have 4 gigabyte of computer memory. So that's the first, very simple view of computer memory. And the C programming language. C programming language. The promise of the C programming language is that it basically allows you to use high-level programming language to write system software, which includes the operating system, which includes device drivers, and later on you can write video games. So it's really general purpose language, but it involves the aspect of systems programming as opposed to just application programming, right? So you can write code that interacts with the database and computes, company's payroll, but on the other hand, you want a programming language which you can use to write an operating system, such as Android or Windows or Linux, okay? And so, therefore, the promise of this language must be that you have direct access to computer memory, which means that this language is supposed to give you access to not just like, variables. If my program is already in memory and this location has value of 65, okay, and the name of this variable is X, besides that, I would like to have direct access to these addresses. Perhaps I can ask X, what is your address, right? What is your address? And I'd like to find out that X is here, its address is 3. And then I can look and see what is located like right next or somewhere else relative to this address. So direct memory address involves working with these addresses directly. So not just naming variables like X and using only variable names to access memory. We also would like to have access to addresses to be able to do even computations with addresses, like compare two addresses and find out how far apart are they, because they may mark the, say, the beginning and ending of some memory block. So we would like to measure how big is this memory block, and we can compare two addresses to find out. So anything that involves, but what you see here, let me just clean this up a little bit and just go back to simple array like this, right? So this is our memory, right? And it's an array of memory cells, blah, blah, blah. We go from 0, 1, 2, 3, 4, 5, all the way down to like 4 gigabytes, or 8 gigabytes, or 16 gigabytes, or 32 gigabytes. Lots of memory, okay? But the model is very simple. But this is all pretty much that we want to be able to use when thinking about the actual hardware. So, without further ado, let's switch to our code window and say, what could we do with computer memory in order to access it directly? What is the promise of the C programming language in saying you can use it in systems programming, meaning everything is available, right? Everything, hardware, all devices, and memory addresses. Okay, so let's see what happens. When I say something like this, hello, okay, when I say hello, what happens is that this, the string literal is, let me just make it a little larger for us. Okay, a string literal like this, using double quotes, places individual characters H, E, L, L, and O in global read-only memory segment. Okay, so let's go back here. So if this is our program in memory, and we said, okay, there's a stack, there's heap, there are globals, and there's text, and so a text like hello. Okay, a text like hello is placed in global memory, and plus it is made read only. Okay, so you cannot modify it, you can only read it. You can only get to the entire string or individual characters in that string. In addition to this, what happens is when it's stored in this global memory, unconditionally, anytime you use double quotes, okay, which is called string literal in C and C++, these guys are stored in this global memory. But individual characters H, E, L, L, and O, okay, and I can essentially try demonstrating it here, right? So supposedly they're stored at address 5, so we get H, E, L, L, and O, okay, so we have the storage allocated, and it just happens to be right here, right? It happens to be, part of our program, and it's stored in the global read-only memory. Okay. In addition to HELLO, there is also a null character. Null character. Appended at the end of every string literal. So we would like to define hello as sequences of characters, but they're intended to use together as a meaningful text of some sort, right? And so instead of storing the length of characters, like how many characters belong to hello, instead what happens is that with every single string, a null character is added at the end. Question, what is null character? Null character is simply character byte stored in memory, which has all bits set to 0, okay? So all bits set to 0, we call it a null character, right? So this is called a null character with all bits set to 0. And so it automatically is appended to hello. But then question, how could I possibly go directly to this memory. I know I have characters in this global memory. I know they're read-only. I cannot modify them. But how could I individually extract these characters and get access to them? Okay, so this is going to be our goal right now, our first goal. But let's just explain how we can access memory in C and C++. So memory, okay, memory is accessed like this. When you want to access this memory, basically internally, your CPU, when it's trying to access this memory, it's using two components. Let me erase a little bit of this so we can. All right. That's good enough. Okay, so when we're trying to access this memory, we use two components. We say our memory begins, and if we want to say it's systems programming, we can point our memory directly to this location and say, well, let's look at the entire memory. So this base address of memory is basically points to 0. Okay. The second component is the offset. The offset. Okay. The second component is offset, usually placed inside square brackets. And what it means is that how many bytes away from this location 0 to a specific character, like this character O. Let me actually make it a little cleaner here, right? So, okay. So if we go from this location 0, and if we want to access character O, basically we need to specify how far away this character O is from this base memory. Okay, so let's try something like this. Let's say if I wanted to display a character stdcout, using stdcout, and I want to go to memory directly, and I want to pick an offset, I can basically say integer memory equals 0, right? Equals 0, and then integer offset equals whatever. It's a big question mark. Let me just hard code it to some hexadecimal value. 0x123 FF E5, whatever, right? Something like that. So, which is completely crazy. It's just like hoping that this memory belongs to me. Okay? So, but this is how you can, and of course I'm using hexadecimal number here, but I could have just typed in some junk value in decimal format. So what I could do instead, I can ask the user. I can say std cout, and I can say enter a. Of course, I need to use quotes, right? And I can say enter an offset, right? And then I can use as the user std_sin. I can say enter this offset, right? And I'm really using like uppercase names for these variables because they're really crazy. I want them to look ugly. I think that generally speaking, uppercase looks pretty ugly, right? So anyway, so that's intentional. And before I do this, I will say std cout and display. This is going to look a little crazy. I will convert this expression into an integer. I'll say, oh, look at these set of characters and make it an integer and try displaying it. And I will say hello is located at, and I will display where it's located like this, and I will add a new line at the end. I will add a new line at the end. Okay, very strange looking code, but let's see how this works. And so here I will add a prompt, and I will say the character is, and I will try using this expression like I told you to display what that character is. Now let me save this segment and we'll start over.